Assalamu alaikum. My name is Iman Arshid. Today we are going to cover some topics like resonance, damping, harmonic series, Doppler effect, and we are also going to discuss about flux, intensity, and luminance. Firstly, we go with simple harmonic motion. Simple harmonic motion occurs when the acceleration of an object is proportional and in opposition to its displacement from the equilibrium position. Basically, simple harmonic motion is a type of periodic motion in which a particle moves back and forth about a mean position. Its mathematical representation is F is equal to minus kx, where F represents the restoring force, k represents the spring constant, and x represents the distance from the mean position. Here, the negative sign shows that the force is always directed towards the mean position. Now, if we go towards the key features of simple harmonic motion, then it is periodic. Its motion repeats itself on regular intervals. Or it is oscillatory. The object moves back and forth about the equilibrium position, and the restoring force, it is a force that acts on the object to return to the equilibrium position. The mean position is the central position where the net force is zero. The displacement varies sinusoidally with time, and the amplitude, it is the maximum displacement from the mean position. Some of the examples of simple harmonic motion are simple pendulum and mass spring system. Now we move forward to the resonance and damping. Resonance, it is the natural tendency to oscillate. Damping, it is the tendency to resist oscillation. Now, resonance, it occurs when an object vibrates at its natural frequency due to an external periodic force. For example, a singer hitting the right note can shatter a glass if the note matches the glass's natural frequency. Now, damping, it is the gradual loss of energy in an oscillating system, reducing its amplitude over time. For example, a swinging pendulum eventually stops due to air resistance. Next is harmonic series and Fourier analysis. A harmonic series is a sequence of frequencies that are integral multiples of our fundamental frequencies. It is a series of harmonics where every harmonic is a whole number multiple of the fundamental frequency. Basically, harmonic series, it is a sequence of sound where each frequency is a multiple of a fundamental frequency. For example, musical instruments, they produce sounds composed of multiple harmonics. And the Fourier analysis, it is a mathematical method for analysis, taking analysis of a periodic waveform to find its component frequencies. Next, we go to the Doppler effect. The Doppler effect is a change in frequency or pitch of a wave that occurs when the source of the wave and the observer are moving relative to each other. It can occur that either the observer is at rest, or the source is at rest, or the observer is moving, or the source is moving. So their movement can be relative. Now, if we take the examples, then a siren, as a police car with a siren approaches, the pitch increases, and as it recedes, the pitch decreases. And the light, the Doppler effect also applies to light waves used in astronomy to measure the velocity of stars and galaxies. Next, we move towards the flux, intensity, and luminance. Basically, the light flux, it can also be called as luminance flux. The total amount of visible light emitted by a source per unit time is light flux. Its unit is lumen. For example, 100 watt of bulb, it emits about 1600 lumens. The light flux, it measures the overall light output regardless of the direction. Then the intensity, uh, luminance flux, intensity, and luminance are all related to how we perceive light. And the intensity, it is about how bright a surface appears to the eye considering the directions. Then about the luminance, it focuses on the strength of light in a single direction, not the total output. We can define luminance as brightness of light emitted or reflected from a surface in a given direction. its unit is candela per square meter. Also, the luminance flux. It is a measure of the amount of light a lamp puts out. The luminance intensity in candelas is a measure of how bright the beam in a particular direction is. We have discussed it earlier. That's all for today. Thank you.